Hey GA Squad, hey Cizzio.
Hey John.
You ready?
Yep.
Excellent. Documents are ready to go for part three of the Synoptic chart videos looking at
Fronts
and
wind direction.
excellent. Let's do it, GA Squad. Come on, Ziz. Wait for it. Okay guys, here we are. We're going to show you what a bunch of these symbols on the map mean. There's two main ones that you need to know that are really important, and that is just here the cold front and the warm front. Both of them are lines. One has triangles on it, the other has little semicircles.
Right, one is far more common than the other. In Australia, we tend to get nothing but cold fronts, but very, very occasionally, like today, ironically and helpfully, we have a warm front as well. But what you're normally going to see when you see an Australian synoptic chart is quite a few cold fronts and not many warm fronts.
The good thing as well when you look at Bureau of Meteorology, this won't always happen in your test, but on Bureau of Meteorology, our cold fronts are blue, our warm fronts are red. Warm fronts, remember, red line here with little semicircles. It's going to bring an increase in temperature as it passes through an area. The cold front, on the other hand, blue line, little triangles, like icicles hanging through a roof. And this is going to bring a decrease in temperature as it moves through the area.
They also both are going to have an impact on the weather that is being experienced by that particular location. So today we're going to look at what kind of weather you can expect if a cold front or a warm front moves through. Okay, here we are. So this is essentially a picture of what a cold front tends to do to the weather when a cold front moves through. Most of you will have experienced cold fronts, especially live on the Australian east coast. Whenever we feel or you hear you're going to get a southerly change and then the temperature drops and the weather becomes unsettled, that's a cold front moving through. So when we have a cooler air mass, it usually comes up from the south because that's where the cold air is, that's why it's a southerly. As it moves in, because warm air is lighter, cold air is denser, the cold air moves in and it pushes the warm air up and above it. Because that warm air is being moved up and above it, that warm air is usually quite, has a little moisture soaked into it. So as that warm air rises, it is moving away from its heat source, which is the ground, therefore condensation happens and unsettled weather happens after it. So normally the cold air moves through and the temperature will drop pretty quickly, and then pretty quickly after that you'll get unsettled weather and storm activity from the moisture that was in the warm air that's being forced upwards. All right, here is a picture of Perth, a satellite image of Perth, and you can see Perth is clear at the moment, but we have a very pronounced cold front moving through. The cold front itself would be a little bit in front of this cloud mass, but as that warm air is going up and over, it's forming clouds as it comes in. Warm fronts do a kind of similar thing, but in reverse, if you like. The warm front sort of moves in and pushes the cool air away, but the warm air is also going up and above, therefore it has a similar effect on the weather. It usually warms it up a little bit, but it can be a little bit of unsettled weather as well. Like I said, in Australia, we tend to get cold fronts, not warm fronts. It's important to know too with warm fronts don't mean it's going to be hot air, it just means it's going to be warmer air than is already there. So you can have cold fronts near the south of the North Pole, not that it's hot air, it's just hotter than it is otherwise.
Okay guys, so what we're going to look at now is wind speed and wind direction. One of the easiest ways, there's two real ways we do this. The first one is with a wind barb. This is probably the easiest way. So a wind barb has two parts that we need to look at. The first part here is called the feathers, and this is part on the end. And this tells us the wind speed at any given location. It's quite easy to do. All you need to check is the legend that's on your map, and each feather or half feather is going to be worth a certain amount. So in this case here, we've been given a question about the wind speed and wind direction using this wind barb, and it's asking for it in knots. So we're going to see here it's got one full feather, so we need to find one full feather, which is here, and then under knots, it's 8 to 12, sorry, which means it must be 10 knots. Okay? The next thing we need to work out is wind direction. And what we need to do is figure out where is the wind coming from, because it's always given as where the wind is coming from. So a southerly wind is coming from the south, and it's going to bring, in Australia, it's going to bring really cold winds. What we do here, the way I always tell students to do it, is you go to the other end, the end without the feathers, and you draw on your compass. From there, it's really easy to read off the wind direction. So in this case here, the wind is coming from the northeast. So it's 10 knots and it's a northeasterly wind. And that's how we use wind barbs to find wind speed with the feathers and then wind direction of the other end. The second way that we can find wind direction is just by looking at these high and low pressure systems that we have in our synoptic chart. So what I'm going to do for this example is show you what the general wind direction would be in Tasmania, which is on our map just here. Now, high pressure systems, we know, in the southern hemisphere rotate in an anti-clockwise direction. So what we do is we find Tasmania, we follow our isobars, and we draw in our wind direction in this anti-clockwise direction. And we can see once we get to Tasmania, the wind is coming from the southeast. So the wind is going to travel around in this direction. It's going to come up from the southeast and hit Tasmania. So it's going to be quite cold winds in Tasmania on this particular day. While we've got this synoptic chart up, we thought it would be good to point out this weather feature happening just here, TC Gretel. And as you can see, this weather system here isn't actually labelled, but we do know from a TC that it's a tropical cyclone. So straight away we should be able to work out, because we know tropical cyclones are really intense low pressure systems. If we didn't know this though, as we showed you in another video, we could also work it out, because if we look at our isobars, it goes from 1004 hectopascals down to 996. So the hectopascals, or the barometric pressure, is decreasing as you move towards the centre. Okay, scored for watching our synoptic chart video. We will be back next week for another skills video.
Yes, we will. We're going to do part 4 of synoptic charts.
Part
Bring it all
4.
together.
Finish this baby off.
How are they actually used in reality to predict the weather?
Really important video. Make sure you check us out on Instagram at geography_explained_online.
Like and subscribe.
Also make sure you like and subscribe to this. And remember, we are here for all of your online geography learning needs.
Just in case for some reason you're going to have to be learning anything online, whether, it's a place to be. It's a good
It's a
stuff.
place to be.
Can I do a special shout out to, we've had a couple of teachers contact us in the last couple of weeks saying that our videos have been very useful for their classes and stuff like that. We really appreciate that. Thank you for showing us around.
See you guys. We'll see you next week. Yeah, 2.
Go.
Oh, look at this.
3.
The last one was my hair.
Also, this is not a soccer ball. This is a globe of the world.
And what is your other excuse, Cizzio?
No.
Wasn't it that you were injured in the leg?
No.
Because you're invincible, of course.
Exactly.
All right, come on, Sis. The record so far is 3.
Oh, hi. How you going?
Hey, Jude.
Whoops.
What's your ice pack for, Cizzio?
I'm hot.
Like that warm front coming through there.